Alright, hello students, welcome to this video class, an online class on 2025 WAEC interpretation to alternative A, practical chemistry. Okay, what we do in this video is to give a background of the quantitative analysis, that is question number 1, and then question number 2, which is a qualitative analysis or identification of ions. And in this video we are not going to be running anything concerning question 3. So as far as chemistry practical is concerned, you are meant to answer 3 questions, or you will be given 3 questions and you are meant to answer all questions. So this video we are going to be treating number 1 and then number 2. You always know that number 1 will always be titration or quantitative analysis. Already have the question projected on the screen. On chemistry practical for 2025 West African School certificate exam, interpretation to alternative to practical chemistry A, alternative A. So we're still going to do alternative B in the next video, but this is A. For those whose registration number falls between 0.0012 to maybe 00040 or thereabouts. So in this question we're going to be looking at the first part of titration, which is the experiment, and then we have the experiment here displayed. We're going to do this experiment step by step, and the way you're going to do it in the exam hall, okay, and nothing more. The success of this the success of question B, that's the second part of this titration, depends on question A. So if the experiment is not properly carried out and it does look like there's errors in your readings or titration, that will definitely affect your B part and the result will not come out very well. But what we're going to do in this video is to tackle all problems, the do's and don'ts that you expected to do as far as number 1 is concerned. So the question here says A, there is an information here, kind of background. A is a solution of 0.219 mole per dmq. You already know that the A has already been prepared. So this is the first step in this practical. You have what they call a volumetric flask here. Okay. This is not for students anyway, so for teachers watching us, the solution or concentration of A has already been prepared, and then we have it in a reagent bottle labeled A. So we've been able to prepare solution A using this standard volumetric flask already, even though that A is not a standard primary reagent, but there's a way we've been able to prepare it. So this is basically for chemistry teachers, not for students. Students are to be given this in 150 centimeter cube. So we have already 150 centimeter cube, and this should be enough for 3 experiments, because the standard number of experiments we are required to carry out in this practical is just 3. I'm going to show you how to do the 3 experiments and then tabulate your readings accurately. The reading is very, very important. Just that table alone, or this particular number 1A question, already carries 8 to 10 marks, depending on what they decide to do in this year's marking scheme. But normally it ranges from 8 to 10 marks, sometimes 12 marks. So you need to be very careful, more especially when you are tabulating your readings. Okay, I think some of these things here are familiar to us, like the one we have here. I think you know what this is. What is this? This is your funnel. Some are made of glass, but what we are using in this video is plastic funnel. So our funnel, this is going to act as our delivery tube. Supposing we want to deliver any reagents, we use it to deliver it, to make sure maybe no part of the solution be wasted. So we use it to deliver solutions, okay, either here or in the test tube. So this is a funnel, and then we have this apparatus. What do you call it? Is a graduated burette. It means that it is well calibrated. In titration, we have two solutions here. The one, just like the one here labeled A, is your titrant. So titrant is meant to be in the burette. That's why you see in the question you have to put A into the burette, and then you know how to titrate it. Run the titration. Titrating means you are going to allow the solution here to gradually mix with the solution that should be in another separate container, which happens to be your B. The B in advanced learning, B is called analyte, something that is being analyzed, okay, or something that you are going to use to analyze something that is here. So the analyte is used to now determine some kind of concentration. The concentration of what is here most often is known. The concentration of what is in B is most often is not known. That's why if you look at the question, they say that B is NaHCO3. That means B is equals to this compound. We don't know the concentration, but in the course of this experiment, we'll now find what B exactly is in mole per dmq. That is the essence of this experiment. In this video, we are going to preempt the examiner, preempting as if we know what is in their mind. Okay, having seen some instructions, and in the instruction there are certain experiment they say that the students should be familiar with prior to this exam. So with that, we try to preempt and see if we can know what is in their mind, and then we come up with this question. So this video, we're going to tackle this question head on, okay, gradually, step by step, without rushing them. And again, in the course of the video also, we also have to explain to you the do's and don'ts, what you should not do as far as this experiment is concerned. There are ways you can carelessly lose your mark. We'll make sure in this video we tackle all the problems. Now, first we're going to start with the first thing they say we should do. We should to put. So if I'm to put here, I'm going to be very careful and make sure that no part of this A is what is spilled out. So I'm going to gradually insert this here and then check again and see what I'm having here is A. You must be very, very, very careful so you don't put B here. So they say you should put A into the burette. You gradually try to put A into the burette. Make sure that here is airtight to make sure that the solution here doesn't drop from the jet of the pipette. So you gradually introduce A into the burette. Gradually, see as I'm doing it. And make sure that you don't allow it to get filled up to the brim. But I think this is okay. Okay, I immediately, after putting this into the burette, please try to remove your funnel. I think there are two reasons why you are removing your funnel, or one reason why you are removing this funnel. Supposing that you didn't remove this funnel after putting into the burette, there are more drops. Maybe after taking your what you call initial reading, one drop from the funnel may have increased the volume, and that will affect the reading. So that's why after now you have to remove the funnel. Suppose you are asked to maybe state two precautions used in the course of this experiment. One of it is that after putting A into the burette, that I ensure that I remove the funnel. Okay, so that you make sure there is no additional volume after taking your initial reading. So that is very, very important. Okay, next, you now try to adjust to take your initial reading. Initial reading is just like the experiment have not started. Okay, so the reading taken before the experiment is initial. It's first reading. I normally call it first reading, and then there will be second reading. That second reading is final reading. So before all of that, before you now take your initial reading, you must go to your question paper or answer booklets, and then ensure, if you look at the question made mention of recording the volume of your pipette. I don't know if I can see it here. Yes, record the volume of your pipette. If you fail to record the volume of your pipette, you may lose 1 mark. Make sure you don't forget that before you even read this burette to take your initial reading. Make sure you just, that part of that question paper, write down your what volume of what pipette. And then if you now look at your pipette, before you take the volume, you must be very sure. Look at it, you see it is written on it here. Though some, is standard for most centers here, we most often use 25. So this is 25 ml, but we no longer use standard units. What we use is what? Centimeter cube instead of ml. So you don't use ml as far as this exam is concerned. So what you do is what? You write what? 25. Okay, some will just write 25 centimeter cube. You have lost that one mark. Okay, part of the instructions they're giving is that they say you should, as a matter of facts, make sure that your initial, your final, as well as volume of pipettes must be in 2 decimal places. I don't think this is a 2 decimal place. So what do you do here? You make sure you add what? Point there, Abby. Point what? 0, 0 what? 0, 0 centimeter cube. Very, very important. It is not a must to write the indicator use, because the indicator is stated as material range. The reason why you must state the volume of your pipette is because there are 2 conflicting volumes there, 20 or 25. So you must tell the examiner which particular one you are using, because already in the report form, the chemistry teacher of a particular center or school, it is the duty of the teacher to state in that report form what the school is using as what pipette size or volume. So as a candidate in a particular center, you must state it so that it will conform with that teacher's what size of pipette recorded. It is very important. This particular question depends on whoever will be piloting the chemistry in a particular center. So it's not wholly depends on this in this video. So this particular practical this particular portion of number 1 is in this video. As far as this video is concerned, or this class is concerned, it doesn't all depends on this video. It still depends on the chemistry teacher, because whatever we are using here in this video may vary with what the center. So please, a disclaimer here. So whatever we're using here as titer value or endpoint is not what it is, because these things can vary from school to school, but the principle still remains the same. I will mean now, the most important is to know the steps taken to carry out an experiment like this. So you see, I've not taken any reading yet, so I must be able to draw a table, something like this. I think you see enough space. There will be space in the answer booklet to do this. So I think I normally tell my students, once they have this kind of box, they divide it into two equal parts. Divide into 2 equal parts, and then divide this side of the parts, which is the right hand side, into 3 equal parts again. Right there, and then come to this side, divide like this into 4 equal parts. So I have 4 equal parts like this. So this is how the table should look like. And then somewhere here, what we are going to read here, this is burette. We are reading the burette. So this is your what? Your burette reading, or readings. Okay. So the first one we write here, even though that's not the first reading obtained, is final reading. Final reading, you make sure that the units for measuring volume, you don't forget it. So next is initial reading. Initial reading. Don't also forget to put the units and then volume of A that was used, also in centimeter cube. So something like this. So you're going to run, like the question said, you should put A into the burettes, titrate it against, what we are titrating against is 25 of P using material range as indicator. Carry out the experiment. So that means this one is for this column. This particular one here now is for this column. So now say here is my what? Experiment what? 1. This is an experiment. But what kind of experiment are you talking about here? We're talking about what? Titration. So all these are titration experiments. So this one is for first one. And I say carry it out 2 more times. So this is going to be what? Experiment. and what? Experiment 3. They can now start the experiment now. So now I can now take my initial reading now. I think I'm not going to use this now. So until we'll adjust to take our reading. So we adjust to make sure that now let me show you something here. What we are having here, let me have a clearer picture of this burette. This is burette. This is the end part of this. Okay, so this is calibrated this way: 1 2 3 4 5 1 2 3 4 5 1. This is 0. So whenever I have a liquid in a vacuum, this is a vacuum flask, a flask that is not that wide enough. It's not as wide as this. So when you have a narrow flask like this, a vacuum flask, you have a liquid inside. The liquid would always have a curve. Okay, the liquid will always have this kind of curve like this. Okay, so this curve is called meniscus, most especially if it is the bottom of it. It's called meniscus, and that is how you read this is how you take your reading from the meniscus. Meniscus means the lower part of the curve of the liquid. So exactly how you will do this. So you adjust to get to that mark. Okay, since it's first experiment, just decide to start from here. I think I have the bottom now settling at 0 mark there. Okay, I'm sure that this should be in 2 decimal places, not just writing 0. This is where you writing it, not here, because the final is the course of experiment. When it is observed that there is a reaction, the reaction has taken place. That is when now the particular point where the reaction has when the whole reaction is now said to be what? Equal. That means the solution here and the solution here is now said to be what? To come to a point of conclusion that there is a reaction which is being accompanied by a color change. That is a point where you are now taking that final reading or the second reading. So, but before the experiment, what you are writing here is initial reading, which also must be in 2 decimal places. So what I am writing here, 0.00. And again, in this video, you are warned never to use this initial for all your experiments. It's very important. Don't use 0.00, 0.00, 0.00. WAEC will penalize you for doing that. In fact, it's not even proper to use 0.00 just because experiment 1 will always be your rough pipe and titration. So whichever thing you have here is what you're going to use to monitor this experiment and its experiment. So most often, whatever we have here sometimes will appear not concordant to what is expected, because you don't have any idea when the reaction when the reaction is complete until after the first experiment. You now know that you have a likely point where these reactions occur. They can now use the first experiment to monitor second experiment. It's just like the first experiment is now serving as a control to monitor second and then third. So you now see that most often your second and third titration readings are most often consistent or concordant to what is required. Okay, that one is gonna. So what we are trying to do now in this experiment is to determine the volume of this one, because already we know the volume of this one, which we have already recorded as 25. So to know the volume of this one, and then to know the volume of this one, that means the reaction must have been completed, which will be indicated by what? Change in the color of the analyte. There will be a change in color here. So until that color change, the reaction is is not complete. So let's see how we can measure the second part. So now let's read the question again. Now we have put A, we have also recorded, we have taken down our first reading, and then we are now asked to titrate it. See how we are titrating now. So we look for B, make sure it's labeled B. And this is your Lemias flask or conical flask. This flask is for mixing. When we start mixing, we use this for proper mixing. This flask is used for mixing the solution from here and the solution from here. Remember, I told you that the solution here is called analytes. Analyte is also called base. So in advanced chemistry, it is called analytes, but here we call it base. Okay, so we have to measure. Okay, just like you have your burette, there is also a mark on this burette. It's not graduated, it's not calibrated, but once you have your solution on this mark, that is assume it is what 25. Then you transfer it to the conical flask. Okay, let's see it. Okay, so you see where we are looking at. So you gradually release until it gets there. Okay, you see it's on the mark now. Okay, transfer, and make sure during transferring, make sure that you don't transfer like this. It's not accepted. And never see this, there's a solution remaining here. Please don't blow the last drop. It's also part of the precaution. So I've given you first precaution that after putting A here, remove the funnel. The second precaution that I ensure that I don't blow the last drop. Don't say, hey, it's still remaining and you blow. It's wrong. This is not designed to be here. This portion is not designed to be here. So once you transfer this solution and it get to the tip, you don't blow the last drop. So you ensure that I don't blow the last drop. Okay, then you have to use, because now listen to me, the color of this analyte is the same thing with the color of here. So if I start to mix these two solutions, there is no point I will know that the reaction is complete. I wouldn't know. So something to indicate that the reaction has taken place here is what? Indicator. The indicator changes color according to the medium of solution. So in alkali medium, there is color methyl orange we show. And which color is that? If I add 2 drops here, which color are we expecting here now? Let's see. I add 2 drops. So minimum is 1, but we can use 2 in this video. 2 drops. Okay, that's maximum. If you use 3 drops, it could be overshooting at the end point. So that's why we use 2 drops. What's the color? Yellow. So what color are we going to be looking at? Our end points here. End point. Okay. Now the color can be orange or what? Pink. But you know the orange is more like theoretical. Orange is what they call equivalent point, where the amount of hydroxyl ion here is equal to the amount of hydrogen ion here. That is equivalent point. But as far as this experiment is concerned, they cannot be equal. One must eventually be the excess reactant. Excess reactant is the one that is what? That will be remaining. One must be used up. And which one do you think will be used up first? Now, before you know which one is used up, you should know the color of methyl orange if it is acidic. What is the color of methyl orange if you add 2 drops of methyl orange in acidic medium? That should be pink, isn't it? So that means the color change, which is pink, shows that the one that is in excess is what? Is the acid. The one that is used up in the reaction is what? The base, because the color here will disappear, and then it does look like the pink will predominate or become predominant as far as this reaction is concerned. So this is the point that the reaction is complete, or what we call the end point. You don't call it equivalent point because it's practical. Equivalent point is when you have H plus is equal to OH minus. That is called neutralization reaction. But this point, we cannot achieve them. We cannot achieve equal here because experiment, one or two things will differ, and then we cannot have exactly equal of this and equal of this. That's why it is called end point and not what? Equivalent point. Are you with me now? The difference between equivalent point and end point is that the equivalent point is more like theoretical. End point is what? Practical. It's practical. We're carrying out practical. If it is related to practical here, you use equivalent point. But this is a very practical, whereby there is no, it's impossible for this one to be equal with this one practically. Are you with me now? Maybe 1/2 drop will change that narrative. So it will not always be orange, but what? Pink. Okay, now let's start it. So we do until something happens. Okay, As you can see, you're seeing that the color will come and go. That means that there is more hydroxyl ion here than H plus. H plus is here now, but they are not equal yet, because it just show that the one that is nearest now, since this color is still yellow, is hydroxyl ion. That is an active ion of a alkali. So we continue until something happens. See, it will come and go. You do this until this color, that pink becomes permanent. Is it permanent now? That's where you stop. That's where you stop. And then you read. Okay. What I'm having here is 21.80. Are you with me? So the one that I used, since I started from 0.00, is the same thing here. So what should be here? 21.80. This is the first experiment. You do this experiment again and again. That's what the question say. You should run the experiment 2 more times. This is the first one. You do it again. So again, done. Now I want to start the next one. Now it's not always it's not a must that after if you want to run the second experiment, you refill again. I can decide to start this experiment from here. It's as simple as that. So I can decide to bring this one here as my initial 21.80. Okay, and then do this second experiment. Okay, now I'm going to, okay, you discard. Sometimes you don't wash. Some people start washing this. You don't need to wash. You just see if you can do it like this. It's already air dry immediately, so you don't need it, because if you're washing, that means water is no longer titration but water titration. So you don't need water here. What you need is acid and what? Base. That's why it is called acid base titration. So if you put water here and start to rinse, it's no longer acid base titration. So now that I already have my initial ready, the next is to measure the volume of the base again. Just like what I just did in the first experiment is what I'm repeating again. I'll do it 2 more times. So I'm doing the second experiment, so I check to be very, very sure of what I'm pipetting, so I will not pipette a wrong reagent. Okay. Okay, I think it's there now. Make sure this one doesn't enter. So we already have 25 already. Okay. To avoid overshooting, don't add 3 drops. Okay, now I've already recorded the initial. Now let's work it out. The reason why you are swinging or shaking it is to make sure that the color is homogeneous. Okay, it's not the case where the purple is only at the middle. Is not. So shaking will help to obtain homogeneity in the mixture. So that's the essence of this shaking. So whichever thing you are doing here, you should know the reason why. At this point, you need to be adding the solution gradually, so that the reading is more accurate than the one we have earlier. think if you look at the color, it's not as that of the first one. That means that this one is more correct than the other one, because now, and the second experiment now is like I'm trying to use this one to monitor this one, making sure the points starts using drop until I know when exactly one drop changes it from yellow to what, to this color. So it mustn't be that shouty. I think this color is enough. If you look at it very well, some can see it as orange. So anybody that the endpoint color is orange is not wrong. Pink is not also what, wrong. Even some say they can even take red. Okay, now let's watch it. So if you're not comfortable with this, you can still bring it up so that it can be at your eye level. Okay, to avoid error due to parallax, you can just look at it like this. Okay, so you don't like bend or start to look, so you can just bring it like this, so you'll be very correct and accurate. Okay, so here now, like I said, I have a 42.90. So I think you know how we're going to obtain this something here. What do you do? What subtracts? 21 point what? You see how far this one is? You see? So that means the next experiment, you must make sure that the last experiment should be consistent with this one. If I want to tell people that if you since it's an exam condition, I believe sometimes students don't know the endpoints. It's no longer something that is hidden. Sometimes you are given the endpoints. So what you do is just confirmation in the hall. But in this video, we teach you how to get the endpoint accurately. So what I will do, I must make sure that the endpoint now settles at the next one settles as this. I will make sure that the next one is going to be 21.20 or 21.00. I must make sure I got any of this reading. Okay. What WAEC is checking out, I think we cannot use this. You see, it varies high, so it varies. So what WAEC is looking at is plus or minus 0.20. Okay, what this thing simply means is that if you use this, if you minus this from this, the range is not going to be within this. I don't think it's within this. What do you have here? If you 0.70, you see, it's very high. So that means the next reading now, supposing that this is what I obtain in the next reading now. So if I do plus or minus, if you say this minus this, you now see that the thing is settling as plus or minus, because anyone you use, any both side, will still give you 0.10, which is very correct. Or even this one, any of these two can go. So what people normally do now at this point now, they will now forge this one immediately to make sure that it's concordant. What they are looking at is concordant. So once after the out of the three experiments, 2, if 2 is consistent reading, you are good to go. But after this experiment, if the 3 of them are not consistent, after checking it plus or minus 0.20 and none is correct, that means you have to repeat the experiment again. And I tell people that this as far as this exam is concerned, nobody is giving you such time. You just have 10 minutes to run this particular one before you now go to section question B of that particular question. Okay, so that is it. So we now try to do the last experiment on this. Okay, now I know it can be possible for us to use this again, because you can exhaust this without the reaction, without the reaction complete. You can't continue the reaction from this. So what do? You refill. This is where you refill this point. You must what? Refill it. So but refilling, don't use 0.00 again. You can use value like 0.5. Okay, you can use value like 1.0. Okay, don't use 0.0. Like I've in the past, they will penalize if you use 0.00, 0.00, like you see in most past papers. Is no longer obtainable. Things are evolving, things are changing. So use something else that is not 0.00. I've said 0.50 is perfect. So that's what I'm going to be using in the last experiment now. So I fill until even if it's not exactly 0 point, I can always adjust. Okay, like now I can always adjust. Please remove this immediately, like I said. Okay, so you adjust, you get that your choice initial. Okay, I think I'm there. And then this one is settled, so you 0.50. You must make sure it's into decimal places. So let's get our base measured. Okay, that's the last experiment now. I can be very fast now because I already know where I will start to control the mixing. I think I can start. See, it does not change. We cannot go with this color. We can't. So the white is reflecting, so it's not yet. I think it's okay now. Okay, someone can come and check and see that at this point I have 21.20. So please, how do we obtain this value? You subtract now. So what do we have now? 21 point what?
No. 20 points.
Is it 20? 20.70. Okay, this is where the problem is. So if it is something like this, what we will do? Okay, what we'll do, we'll adjust. Maybe you add on T. Okay, so it was supposed to be 21.90. Okay, now subtract. Let's see. 21 point what? 40. Okay, now you have to still. You need to adjust it until it's consistent. So what we need now is either of this. So choose one. Which one are we choosing? Let's choose 21.20. So add this thing up. Let's know the correct value that should be here. Add up. It will be 21 point what? 70. So make sure this minus this will give you this. That's correct. So this is how to adjust it. So you'll be very fast. So now these two reasons is very, very correct. So we can now conclude this part now. Then to conclude this part, because it's a question now that we're done with the table now, they can now say record, we have recorded it already, tabulate it already, we've done that. Then there's something that should be there after this. Calculate the average volume of acid used, which is going to be what? Average volume of A used. What do we use here? We use experiment what? 2 Abby plus experiment 3. Then we are using 2 Abby to divide. So what do we have here now? 21.10 plus 21.20 divided by what? 2. What do you have now in total? 21.15. Check if it's correct. Centimeter cube. Check if it's correct. And again, I will just say two things here now. This table now, both initial and final, you can see they are in 2 decimal places. You see there are units here. Okay, you see there are units. So they are in 2 decimal places. And please, no form of mutilation. You're going to be penalized if you mutilate or you after recording and writing the table after using pencil. You now encrust it with bic. They also penalize you. They believe that this experiment should be yours and you alone. So you don't need to change any figure. You don't need to mutilate. You don't need to cancel. So make sure before the table you are very sure that this experiment is correct reading. I mean, you must make sure, you must run it somewhere and then be very sure before you now transfer it to your what do you call it, your examination booklets or exam papers. So this is what you do. So make sure it's not dirty, it's not much cancellation, no much cancellation. You can see there's no much cancellation here. You get your reading here, then you are sure of your 10 marks or 12 marks or 8 marks depending on the location of marks. So let's quickly go to question number B of this question. Question number B part of the question will be on calculation. We are done with table work now, so whichever thing that we obtain now, we're going to use it to solve the bigger problem. So now we need this titration average value volume. We need it, so I'm going to write it somewhere so we don't forget it. So let's write it 21.15 centimeter cube. Or whenever you see this, please always see it as your volume of what? Acid, VA. So it's going to be helpful here to solve these problems here. So you can see the B part now. So whichever thing we're going to do in the B part is what already what we have, the readings that we have obtained. These are what we're going to be using here to solve this B part. So the next one say from your results, this is the result, and then information provided. What are the information provided? You see the first question, they say A is this with a certain concentration, and B is this. That is what they mean by information they have given to you. Then that you should calculate the concentration of B in mole per dmq. So this question should be the first question. So this is where the question: calculate concentration of B. This one should be A, this one should be B, this one should be C, this one should be D. So let's correct it so you don't see that. So there's a question here that I should solve, which say concentration of B in mole per dmq. Okay, in this video we're going to show you step by step how you will calculate this parts of this titration question without hitches in the exam hall. Now, if I were you, before I answer this question, I'll first of all look at the two reactions. The two reactions are HCl, I think, which is what? In aqueous form. Which is in aqueous form, isn't it? Okay. So another one is what? NaHCO3, which is also in aqueous states. And then what are we having here? Normally in acid-base reaction, there will be salt, isn't it? Salt is part of this and part of this. So what we have here is what? NaCl. Please be silent. Okay, so now what do we do now? The next thing now is water now, isn't it? So what are where is the water going to come from? H here is giving us what? H2, and we'll pick one O to complete it, and then something is remaining. We're not going to throw this one away, so we're going to have what? CO2. The equation is not straightforward, so you're not going to have more numbers here again. So with this now, you now know that the ratio of these two is 1 is to what? 1. So I cannot just say mole ratio of acid, and this is the acid, to base, this is the base, is what? 1 is to 1. So everything now is settled. I have every parameters. Now I'll show you. So since I have every parameters, I cannot say using CA, but if I don't have every parameters, I cannot use this VA all over CB VB, and let it be equals to these two, which already know that number of mole of this is A, number of mole of this is what? B. You don't start solving immediately. You don't start to solve, okay, cross multiply. You don't do that in chemistry. As far as chemistry is concerned, don't do that. You have to state what you are doing. Tell them you will do what? Substitute. You substitute these things. If you go to that question, from the beginning of that question, They gave you concentration of A there. Please, someone should help me there. 0.219. Are you there? You may not even need to necessarily write that one there. Times VA, just what we've just obtained now from that table. That's the average. So that is the volume of the acid that was unknown. Now we know. So we now plug it here as what? 21.15 over. We have nothing for CB. So we are writing CB as CB. Okay, that's the question. So times, we already have recorded that volume of base, which is what? 25.00. Let everything be equals to the mole ratio, which is what? 1 all over 1. Please, the error of doing this as cross multiply is gone. So what do? You want to cross multiply. You write you want to cross multiply. You write cross multiply. And if you want to cross multiply, start like this, so that this CB side will be on the left hand side. So 1 times this times is going to give us what? 25 CB. You may not need the zeros again. Equals to this times this times this. Someone should help us with the numerical. This one times this one times this. 4.638 what? 5. So this is what we have. Is that correct? Okay. 4.63. So 1 should be here. 1 8 what? 5. Is that what we have now? Okay, correct. Now that we have it like this, what do we do next? You what? You say you what? Divide both what? Side by this CB coefficient, have you? Divide both side by who? 25. So you now say 25 CB, you divide by 25, equals to this side 4.63185. Also divide by what? 25. So that CB alone now is what? 0.185 what? Now let me tell you now, in this case now you don't need all those long numbers. So far you have this number is okay. Just whenever you have something like this. Okay, please, we need one more number. 0.185 what? Okay, sorry. No, you don't need nothing. So it's okay. Trace enough figure now. What do you have here as the unit here? Mole per what? DMQ. That's where you stop. That is the concentration of what? B in mole per DMQ. Then now that we now have B in mole per DMQ, it will be very simple now to find the B. Now to solve this particular one, this one is going to be our question B. Question B. This is question A. So there's a mistake here. So here should be B. Here should be A, B, C, and D. Okay. So this particular one, I say we should find B in gram per DMQ. Now look at what you do. This is B in mole per DMQ. Please watch this. This B in mole per DMQ is called molar concentration. So I always know it as molar concentration is equals to mass concentration. The mass conc is gram per DMQ. That's what you're looking at. Mass concentration divided by what? Molar mass. So if you state this formula to solve the problem, you already have your 1 mark. Then if you go ahead to now tell the examiner that but molar mass, let me use short form, molar mass of base is NaHCO3. If you solve to find the molar mass, they'll give you your 1 mark. If you didn't solve it and just plug in something that you solve somewhere, you just know that you have missed that mark. So just state it, just relative molecular mass. This you just add every relative atomic mass of every individual element in that compound by saying 23 plus 1 plus 12. 12 is this one here, plus this one is 16 and it's 3 of it in here. So what do you have here? 48. All together, what do you have now? All together 80 what? Confirm if it's correct. 84, right? Is it correct? 84, 86. Good. Now we now know what to plug in here. We have molar conc to plug in, therefore here now I'll plug 0.185 is equals to, I have nothing to plug in here. So here when I say mass conc, we don't know mass conc, or you can even use X there. Divide by what? Molar mass 84. And we'll cross multiply at this point. If we cross multiply now, you're going to have, now let me finish it here. I'm going to say therefore mass conc now, mass conc is equals to 0.185 times what? 84. Is that what I have here? 84, 82? 84. 84. So what is my answer here? 15 point what? 5 what? 4. you can keep it as what? 15.5 what gram per what dmq.
So that we'll get it straight.
Okay. Okay, now what we do now is we want to have everything okay from here. Okay, let's have this question resolved again. A part of it from a result. First of all, HCl plus NaHCO3. So what do you have here now? This we go with this, Abi. NaCl plus H2O plus CO2. Once you finish this, you write this 1:1. So from the equation here, mole ratio is 1:1. So using Ca Va over what Cb Vb equals to NaL over what Nab. So we substitute already. We are given that a Ca is 0. Help me with that. 0.219, isn't it? Times what? 21 upon Cb times 25.00 equals to 1 all over what? 1. Okay, so I've told you the error of this is gone, so just show this cross what? Multiply. So what do you have? Go this first. You have what? 25 Cb equals to 4.6. Is that what you have here?
Yes.
Okay, this time you divide, show all workings. You want to do any step you are doing, just make sure you state what you are doing. So at this point you say you what? Divide both side by what? 25 Cb 25 4.6185 25, so that Cb alone now is what?
0.185.
what? 5 mole per dmq. Then B, then now you know your molar concentration, so you can now find your mass concentration, but use this formula. So you use molar concentration, look at it here, is equals to mass concentration you are looking for over what? Molar mass. But like show this working to earn your 1 mark, but molar mass of NaHCO3 is what? 23 plus 23 is for sodium, plus 1 is for H, plus 12 is for C, plus 16 times this is this, isn't it? So everything is what? 84.0 gram per mole. This is the unit for molar mass. So now plug the figures. You have 2 figures now, you cannot find this, isn't it? So you now say, okay, so under here you're going to place what? Fix 0.185 equals to mass conc Abi over what? 84, isn't it? So you cross what? Again, cross multiply. So if you do that, you now have mass conc now Abi is what? This times this is what? 15.5 Abi gram per what? dmq. That's the answer. Then this is B, so let's go to C. So this is going to come in as C. So if you want to solve the B parts there, still that is still B, so still with base. So but what you need here is just this ion, so you have to split this equation into this and this. So we have gotten this is what we need. No, find the number of particles here. How many of these are splitted into this? How many of these are splitted? 1. How many of these do I have here? 1. Remember, this is negative, okay? So they balance the charge here. Alright, there. What is the concentration of 1 mole of this? Where is it here? Where is the concentration? Let's look at it here. 0.185. If this is 1 and this is also what? 0.185. If you cross multiply, like I told you, the error of this has gone, but let me just do it here. The mole of this is the same thing as the mole of this, the same thing, because assuming that we have these 2 mole here, would have doubled the concentration. But since the 1 mole of this give me 1 mole of this, so the molar concentration of the base is the same thing as its ion. Do you get the point now? So now we can now go ahead to find the number of particles. So this is the mole now in 1 dmq, mole of this in 1 dmq. So therefore, number of mole of this particular ion is equals to number of particle. Are you with me now? Number of particle, let's use a symbol of particle n over Avogadro's number Na. So let's use symbol for n of number of mole is what? N. So this is n will be here, and 0.185 equals to n is the number of ion, the particle we are looking for, which we don't know yet, over Avogadro's constant of what? 6.02 times 10 to the power of 23. You get your answer now. So what is n now? N will be this times this. So that's the number of ion of that particular radical in the base. Then you want to solve for the mass of sodium ion. Look at it here. Just sodium ion. Then you want to solve for mass of sodium ion. This particular C will give us idea to solve that this D now. The C here is our D because of our numbering. So now to solve the mass of sodium ion in B, so that is what we're going to have now. D mass of Na plus in B. So we only have NaHCO3 and they only have one Na plus inside here. So this is what we are looking at. This is 1 mole. This is also what? 1 mole. Molarity of this is 0.185, so this is also 0.185. So concentrate on this and get your answer. So now, of course, your normal mole mass relationship will always be N equals to what? M over what? M, period. What is N here? 0.185 equals to M. What is the mass of sodium? 23. Although even though the error of this has gone, but let me just use it here. So what is M now? M is this times this. That's the mass of sodium ion in the base. Please sharp sharp. What's the answer there? That's exactly 4 point what? 2 what? Is 25 is okay. 256 is okay. 25 what? 6 what? Gram. Okay. What? Okay, for C. No, the questions are like this. We have A here. Calculate the concentration of A, B, C, D. Okay, the end answer of, okay, what's the end answer here? 1 point what? 11 times 10 to the power what? Again 1.11. Hey, it's too much now. Let's
137. So that is 1.114.
1.114. So 4 should be here. We don't need this much distance. So 1.1 is okay. 1.1 times 10 to the power what? 20 what? 3 guinea. What are we looking here? What are we looking for? Number of mole of what we are looking is what? Is what? Ions. So that is the number of ions of that particular radical in that space. Okay, so examiners WAEC will always have a twist to this. So whichever way they ask this question, you should be able everything You solve everything the same principle, the same step. You use these to solve and then get the answer. In this video, you're going to see this question. We are not assuring 100%, but you're going to see it's up to 85%. 85%. That is, if you understand what we did in the video, how we carry out the experiments. You can then go back, check what we have done to be able to know steps taken. The most important, the success of this exam remains in the question A, the A part, which is experiments. Supposing you are in a school where everything will depends on your effort, that means you must run the experiment and then get your values and then carry out the titration, the calculation part of it. So if there is anything that is wrong with the experiment, I bet you it will affect this part, and this part is where the bulk of the mark lies. This is where the bulk of the mark lies. I think you should be having up to 14 to 15 marks from this portion. 13 to 15 marks from this portion. Okay, now let's go to number 2, which is another area of analytical chemistry, which is on identification of